Hi friends, so let us start with a new set of videos. This will be about polynomials. Okay, again it's in a question and answer format, very easy to follow. So what is a polynomial? A polynomial is a mathematical expression of type 3x plus 4, 2x squared plus 4x plus 5, 3x cubed minus 8, etc. Okay, this expression has three things. One, it has a variable, x in this case. It has terms. See, each of this term separated by plus. See, 3x is one term, 4 is another term, 2x squared is another term, 5 is another term, 4x is another term. So it has these terms, and each term is having two parts. One is the variable with a power, and another is the constant coefficient. Okay, so this is how a expression is made. For example, if we take 3x plus 4, 3 is a constant coefficient, 4 is just a constant, and x is the variable with the power. In this case, we have power of 1. So x power 1 is equal to x. Okay. Similarly, if you look at the second example, the 2 is a constant coefficient, the 4 is a constant coefficient, 5 is a constant, x is a variable here with power 2, x is a variable here with power 1. Okay. So this is how our expression is made. The general form of the polynomial expression is an x power n plus an minus 1 x power n minus 1, all of them continually till a0. Okay, so an minus 1, a0 all are constant coefficients, and x is the variable. See, variable is the thing which can take any value. Okay, constant cannot change value, but x can take any value. In 3x plus 4, 3 and 4 are constants. They are constants or constant coefficients. They cannot change the value, but x can take any value. Okay, that's the difference. Give examples of linear, quadratic, and cubic polynomials. An example of linear polynomial is where the maximum power of the variable is 1. Okay, so for example, 10x plus 2. Here you have a variable x and its power is 1. There is no other term where the variable appears with a power greater than 1. Therefore, it is called a or another example is 7x plus 13. X has the power 1. Therefore, it is called a linear polynomial. What about the quadratic polynomial? Quadratic polynomial is where the max power of the variable is 2. Okay. For example, ax squared plus bx plus c. Okay. Or kx squared plus lx. Or dx squared plus g. See, all this a, b, c, d, g, k, l, everybody is a constant. But here, the x has the maximum power of 2. Okay. Here, a constant is missing. You have a variable with power of 2 and variable with power of 1, but no constant. Okay. But still, this is a quadratic polynomial. Here, you don't have a term with x power 1, but still the maximum power is x power 2. Okay. So, this is still a quadratic polynomial. What about cubic polynomial? Here the maximum power is equal to 3. For example, ax cubed plus bx squared plus cx plus d. In this polynomial, you have variable with all the powers, to the power 3, to the power 2, to the power 1, etc. You can have only one term, ax cubed, that is also a cubic polynomial. You can have ax cubed plus cx, where x squared is missing, constant is missing. This is also a cubic polynomial. Okay, you could have ax cubed plus a constant d. Okay, that is also a cubic polynomial, because everywhere in this case the variable has the maximum power of 3. Okay, next question. What is the degree of polynomial? The degree of polynomial is equal to maximum power of the variable. For example, if you have a polynomial u power 6 minus 3u squared plus 1, here you can see that the maximum power is 6. So this degree of this polynomial is 6. Similarly, z power 8 minus z. Okay, now the maximum power is 8. So the degree is 8. And simple, if you take ax plus b, the maximum power is 1 because you have x power 1. So degree is 1. Okay, so degree of the polynomial is equal to maximum power of the variable. Give some examples of expressions which are not polynomials. 1 upon x squared x minus 1 is not a polynomial because the expression is in the denominator. Such expressions where the polynomial expression is in the denominator are not considered as polynomials. Similarly here, root of x plus 2. See, the power of the variable is half. Root of x can be written as x power half. Wherever the power of the variable is not a whole integer, such expressions are not considered to be polynomials. Again, here x squared plus 2x plus 3 is there, but it's in the denominator. So this is also not a polynomial. Next question. How to find value of a polynomial, okay, given the value of a variable? Okay, let us say I give you the value of the variable. The variable could be 1, it could be 0, it could be half, it could be minus 1.3, anything, because it's a variable, it can take any value. But given the value of the variable, how do we get the polynomial's value? If we are given the value of the variable x, to get the polynomial's value, we just need to substitute the value of the variable in the polynomial. Okay, I repeat, to get the polynomial's value, you just need to substitute the value of the variable in the polynomial. Example, let's say we have a polynomial p of x is equal to 3x plus 4. Okay, now if x is equal to 2, what is the value of the polynomial at x is equal to 2? It is denoted by p of 2. So instead of x, we will substitute 2. So 3 into x, so 3 into 2, plus 4 plus 4. Okay, so what is the value of this polynomial when x is equal to 2? It is 3 2s are 6 plus 4, 6 plus 4 is 10. So the value of the polynomial at a particular value of x is got by substituting for x using that value. Okay, if x is equal to minus 4 by 3, what is the value of the polynomial at minus 4 by 3? It is 3 times substituting for x by minus 4 by 3 plus 4. See, this 3 cancels, this minus 4 plus and minus becomes minus. So you get minus 4 plus 4, that is equal to 0. So the value of the polynomial at when the variable is minus 4 by 3 is equal to 0. Okay. Similarly, we can have another example. If you have a polynomial which is quadratic, you have 2x squared plus 4x plus 5. If x is equal to 2, then polynomial at the value of x is equal to 2 is equal to, substitute 2 instead of x here. So 2 into, instead of x squared, we have 2 squared. Instead of 4x, we have 4 into 2, and 5 is written as is. So 2 squared is 4, 4 2s are 8. Here 4 into 2, 8, and 5 is there. So 8 plus 8 is 16, plus 5 is 21. Okay. At x is equal to 0, what is the value of polynomial? Again, substitute 0 here. 2 into 0 squared plus 4 into 0 plus 5. So 0 squared is 0, so this term becomes 0. 4 into 0 is 0, this term becomes 0. Only 5 remains, so 5 is the value. Okay. Take another example. This is a cubic polynomial. Okay, 3x cube minus 8. When x is equal to 1, the polynomial's value at x is equal to 1 is nothing but 3 into 1 cube. Instead of x, we have substituted 1 cube minus 8. So 3 minus 8, that is minus 5. When x is equal to 0, p of 0 is 3 into 0 cube. 0 cube is 0, this term cancels. Minus 8, 8 remains as is. You get the value of minus 8. Okay. What is meant by 0 of a polynomial or root of a polynomial? Okay, the value of variable x for which when you substitute it in the polynomial equation gives you an answer of 0, such value of x is called 0 or root of p of x. I repeat, you take a polynomial p of x, and for some value of x, this polynomial's value will become 0. Okay. That value of x is called the root or 0 of the polynomial. Example, let's take p of x is equal to 3x plus 4. When x is equal to minus 4 by 3, if you substitute x is equal to minus 4 by 3 in the polynomial, p of minus 4 by 3, 3 into minus 4 by 3, okay, minus and plus will give you minus, 3 and 3 will cancel, you get a minus 4 here. The polynomial already has a plus 4 which is written as is, so minus 4 plus 4 you get 0. Therefore, x is equal to minus 4 by 3 is the root of 3x plus 4. At x is equal to minus 4 by 3, the polynomial 3x plus 4 becomes 0. Therefore, x is equal to minus 4 by 3 is a root of this polynomial. Okay. Take another example. X is equal to, p of x is equal to x squared minus 3x plus 2. Okay. When x is equal to plus 1, the polynomial's value, substitute 1 for x, you'll get plus 1 squared here, minus 3 into 1 plus 2. So 1 squared is 1, minus 3 is minus 2, plus 2 is equal to 0. Since you got the polynomial's value of as 0 when you substituted for the x as 1, x is equal to 1 is a root. Okay, substitute x is equal to plus 2. So plus 2 whole squared, x squared plus 2 you substituted, it become whole squared, minus 3 into x into 2 plus 2 whole squared, 2 into 2 is 4, and here plus 2 you'll get 6, and you'll get a minus 6, that will result in 0. So 2 is also a root of this polynomial x squared minus 3x plus 2. How about 0? Is 0 a root? To check that, just substitute and see. P of 0, you'll get 0 squared minus 3 into 0 plus 2. These two terms will become 0, but 2 remains. So the value of the polynomial is 2. Therefore, which is not equal to 0, which means x is equal to 0 is not a root of this polynomial. So in summary, x is equal to 1 and x is equal to 2 are roots of polynomial p of x is equal to x squared minus 3x plus 2. However, x is equal to 0 is not a root of p of x.